We're going to move forward now with our knowledge of scales and scale factors and scale ratios and start to use this information to help us draw any 3D object to scale as a drawing. So the first drawing we're going to do, I'll just show you what it looks like. We're going to be working with this birdhouse, and it has dimensions on it. And we're going to want to draw each face of it. So each face means its front, its sides, its back, its top, and its bottom. So we'll go back and look at the definition. It's saying a view or an elevation is a flat representation of each side or face of a figure. Now you would have taken these sort of things in junior high when you had a collection of cubes, and it would say, what would this collection of cubes look like from the front, from the side, from the top? You would have done things like this already. So the first birdhouse diagram, we're going to be working with the views or the elevation. The second part of this lesson is going to look at, excuse me, this box, and it's a toy box, and it's saying construct a component diagram for this. Now the component diagram is just talking about what are the pieces of wood that we need to make this, and that's the second definition on this front page, and we'll get to that when we get to the second example. So when we first start here, we have this birdhouse, and we're going to want to draw this birdhouse to scale. But in order to draw anything to scale, we have to pick a scale first. Now I went through and I looked, I see 9, 10, 5, 6, and I'm saying, okay, I need this somehow to be represented by something I can draw and fit on the paper. So I'm not going to actually draw it 10 inches deep or 9 inches high on this piece of paper. So I'm going to give you some simple steps when we're creating these diagrams on what we actually do. The first part is to just choose a suitable scale. Now your scale might be a little different than the person you're sitting beside or you're working with, but as long as your scale makes sense to you and you draw your diagram to that scale, that's good. The second thing that you do is convert all original dimensions to drawing dimensions. So there's that whole drawing to original, or the Dr. Orr that I've been referring to. So we're going to convert them using the scale. And then last but not least, once we have that done, our third step is to just start to draw it. Get in there and draw it. So we'll look at this and we'll talk about the scale that I think would probably be really good to use here. I'm seeing 10, 9, 5, and 6. To me, randomly picking a scale, I'm going to pick something that's easy to work with. So my scale that I've decided would be 1 centimeter. On my drawing, there's the Dr. to the Orr, would be 2 inches on the original, or 2 inches in reality. So this is the scale I'm going to work with. And that means now I have to take the 10, the 9, 5, and the 6, and actually convert them. That's the second step. So let's start with the 10 inches. If I looked at 10 inches, I'm having 1 centimeter is 2 inches. The 10 inches is an original. So if we're saying Dr. Orr again, drawing to original, it's there. And we're going to use this now to cross multiply, which we've had a lot of practice with. So that's going to be 1 times 10 divided by 2, which is 5 centimeters. So the 10 inches, excuse me, I need to draw in my diagram to be 5 centimeters. And we're going to do this with all the dimensions. So the 9 inches has a 1 to 2 scale. 9 inches is my original. If I cross multiply, 1 times 9 divided by 2, that would be 4.5 centimeters. So this side, when I draw it, is going to be 4.5 centimeters. Again, we can do it with the other dimensions. The 5 inches, we still got a 1 to 2, which is something over 5 in my drawing. 1 times 5 divided by 2. Some of you might be picking up that this is actually just dividing all these dimensions by 2. That's why this scale was a nice one to work with. So that's the 5 inch, the 6 inch, 1 to 2, something over 6. Cross multiplying yet again. And I got the 3 centimeters. So I can just show myself what I need to be drawing all this. This would be 2.5, This would be 3 centimeters. Now we are doing a very simplistic drawing here. It's not giving us the dimension of this, the actual opening, the hole, or the dimension of the stick on the front. We could represent those in our diagram, but it's not giving it to us. So let's now go ahead and look at how we would actually draw these. You are going to be required to use a ruler to draw these to scale. So I went ahead and drew these with our scale. It does say that we want to label these after with the dimensions, so we'll take a look. Here's my ruler, and it's in centimeters. So if I was looking, the bottom of this, the bottom shape is the rectangle that this birdhouse is actually sitting on. It's right here. And that bottom shape is 10 by 5. So on my scale, the 10 by 5 is going to be 5 centimeters long and 2.5 centimeters. So here's the rectangle, and you can see that I made it 5 centimeters long, and I made it 2.5 centimeters. Whoops, 2.5 centimeters wide. Okay, so when we go to label it, we should label it always in the original dimensions. So this is the 5 inches, and this is the 10 inches. And we can go through and look at all the other sides. The front of the birdhouse, one thing missing that we don't have the dimensions for, but the stick, we could see when I measured it, this thing should be 9 inches high, and so there's 4.5 inches from the top to the bottom. But remember, our scale was 1 to 2, so 4.5 centimeters does equal 9 inches. If I look at how wide the roof is, the roof was supposed to be 6 inches wide in the original diagram. So when we look here, the roof is 3 from tip to tip. The actual width of the bottom, which is supposed to be 5 inches, we made 2.5. Okay, there was no dimension on the hole, so we just put a random one in there, and from the front we'd see that peg as well that's standing out. The back is the complete exact diagram as the front minus any holes, so the dimensions are exactly the same. Now the sides, if we were looking at the side of this birdhouse, it's still going to be 9 inches to the top of it, and it's going to be 10 inches deep. So we'd be making it the 5 centimeters in our drawing and the 4.5 centimeters tall in our drawing. But the one thing, if I was looking directly at the side, two-dimensional, I would see a line somewhere where that roof is hitting or overlapping the side. So here, we can go and we could say, here's the side of this. So this is 9 inches tall, 10 inches deep, and we got that. The top of it, if I was looking straight down at it, it's still going to be 10 inches long, but now it's going to be 6 inches wide. That was from tip to tip. And you could see we put these, this would be the top of the roof of the house where it's going down. So you can see that we did draw a line, because if we were looking straight down on here, we'd be able to see that as well. So I'm going to go through, I'm going to put the dimensions on here that I need. 6 inches, this is 5. And this here is the 9 inches, because the question did say to label it. So again, 9 inches, and from roof tip to roof tip is 6 inches, but the width is 5 inches from there to there. So we went through and we did draw these to scale. But now we're going to look at this box. We got Edison building a toy box for his son in the shape of a rectangular prism. The box is 120 centimeters long, 60 centimeters deep, and 60 centimeters high, and you can see it's all labeled on there. This one, it's saying draw the component parts using a scale of 1 to 15. So remember, this is drawing to original. So it's already giving us a scale. We don't need to choose it this time. Now, it says component parts. This isn't the views. We don't want the front, the back, the side, the bottom, all of that. It's just the components. And if we look at this toy box, there's actually only 2 components to the toy box. There's the ends, which I'll show here. So here's one end, and the other end is over here. if we were to look at it. And then all of the other pieces are just the same size. So the sides in the bottom, if you examine the diagram, all the sides and bottom, so here's a side. If you look, it's 120 by 60 high. The other side is going to be 120 by 60. The bottom's 120 by 60. So if it says draw the component parts, I only have to draw two things here. There's only two components that make up this shape. But we do have to use the scale provided to us. And there's only two dimensions on here. So we're going to convert our dimensions now. So we have a drawing to original, which is 1 to 15. And if I consider first this 60, so that's on the original, it's 60 centimeters. And I cross multiply this, 1 times 60 divided by 15, that's going to give me 4 centimeters. So anything on this diagram that's 60 centimeters, or on this shape that's 60 centimeters, I'm going to draw to be 4 centimeters. And I do the same thing, the 1 to 15, for the 120 centimeter long side of these. With the question mark, I'll just box this so I remember. So this will be 4 centimeters. And if I cross multiply here, 1 times 120 divided by 15, that gives me 8 centimeters. So anything on this box that's 120, I draw as 8 centimeters. But now, since it's only a component diagram, I only need to draw two shapes. The ends, which are square, 60 by 60, and those longer pieces that are 120 by 60. So I need to grab a ruler. So here's a ruler. I should label what I'm actually drawing. So I'll draw this time in blue. I'm going to draw the ends. Now remember, the ends on this diagram, if we look, are 60 by 60. They're squares. So according to our scale, 6 centimeters in the original toy box is actually 4 centimeters when I draw it. So I take my ruler, and I'm going to use some straight lines here. So there's 4 centimeters. Spin the ruler, and we'll go and measure the other 4 centimeters as best we can, and then finish off my square. 4, 4. So this is the ends of the box, and when we draw them, we should be labeling them with their original. So here's 60 centimeters. 60 centimeters. There's the ends. Now the only other component we have are, the sides and the bottom. And there's 3 of these, the 2 long sides and the bottom, but we only have to draw it once because it's only the same size component. So again, we're going to take our ruler, and these things are going to be 8 centimeters long. So we draw 8 across, and then spin our rulers, and now they're 60 centimeters high, so our scale said that that's going to amount to 4. So we take this, measure as carefully as possible, go down to 4. Right here, whoops, as good as we can on the smartboard. And then you finish off your diagram with the sides and things you need. So this again is going to be 8. And then complete it. So here is the sides. And we just have to say, well, this is 60 centimeters. And if that's 60 centimeters, the width was, or the length of this was 120 centimeters. And our scale, we know it said was 1 to 15. So I drew the component pieces. So the component pieces, if there's some that are the same, you only have to draw them once. Just like in the birdhouse, when we looked, even though there are 2 sides to this, when I did it, I only had to draw the sides once because we knew that they would look exactly the same. So here we were using our scales to actually come up with some scale drawings based on some 3D shapes.